I wanted a C++ programming example to show arrays in a meaningful way, and so this is what we're going to do. We're going to input a set of 8 numbers, so that'll be in our array. And so for our output, we want, out of those 8 numbers that are input, we want to show the highest number, so the largest, the lowest number, and the average of all those numbers. So those are pretty simple, and you could probably do that fairly easily without an array. So to make things interesting, let's find the population standard deviation of those numbers. So to do that, always the first step in programming is understanding the problem. So let's take a look at the definition of standard deviation. The first thing to understand is that there are different definitions of standard deviation, so we want to get the right one. The most common one is not the one we're looking at. It's called sample standard deviation. So if you're looking at a population, very rarely can you take a sample from everyone in the population or everything in the population. So usually you deal with a subset of data, and that's where the sample standard deviation comes in. Slightly different, and so for ours, or for cases where you can sample the whole population, and hence the term population standard deviation. Okay, and if we look that up, we probably get some formula like this, and if you know what this is and you know standard deviation, you can probably skip ahead to the programming part. If not, let's break this down and look at what's going on here. So we'll start right here in the innermost parentheses and see what's going on. So x here with the bar over it is the average, okay, of all the numbers together. And then this x of I here is kind of an interesting thing. The way this summation sign works is I equals 1, and it goes all the way up to the n, whatever the nth number is. So in our case, that would be, if we're looking at 8 numbers, it would go from 1 to 8. And then we're taking x, so some number sub I, so it starts with the first number and then the second number. So very much like we use arrays in programming, okay? So it's going to go through that sequence of numbers, x of 1, 2, 3, 4, all the way up to 8, and then subtract the average from each number. And then if you remember your exponents, this is just going to, after you take the difference, it's going to square it, okay? And then once you add all that up, we're going to divide by n, or in this case it's multiplying by the inverse, or 1 over n is the same thing as dividing by. And then after we calculate all of that, it's going to take the square root, okay? And notice the difference between population and sample standard is what you divide by here. So we either divide by n for population. So if you want to take this problem and change it to the more common sample standard, all you have to do is divide by n minus 1 instead of n, okay? So let's try to translate this into more English-like language so we can really understand what's going on here. So the first step in this problem is going to be, because we need this average, we're going to have to find the average of the numbers first before we can do the second part, which is subtract the average from each of the numbers out of the series of 8 numbers, and then square it, right? Because we have the exponent there. The third part is we find the variance, which is just the average of all the numbers that we calculated in the second step. And then we take the square root of that final result that we found in step 3. Okay, so let's look at some actual numbers here to see what's going on. Again, we need to understand the problem, so let me just pick some numbers here. And so this will be my set of numbers that we're going to work from. And so what we're going to do, first thing is just find the average of all the numbers. So we're going to take the first number in that set, 2, plus 4, plus 8, plus 3, and so on. And then we're going to add those up, right? So we get a total of 56. And then we need to divide that by the total number in the set. So 56 divided by, and we're going to have, by definition, 8 numbers for this problem. and that's going to be equal to 7. So the average of our numbers is 7. Okay, now we need to find the difference between that and each number in the set. So we'll do 2, which is the first number in the set, minus 7, which is the average. Okay, so we'll subtract that and we'll square it. Okay, and we'll need that later on. So 2 minus 7 is 5 squared. Okay, so we can square that and we get 5. Negative 5 times negative 5 is 25, positive, right? So we'll do that for each one in the set. So the next one is 4 minus the average of 7, square that. So we get negative 3 squared is 9, and we'll keep doing that for each item in the set. So 8 minus 7, that one's just 1 squared, which becomes 1. 3 minus 7, negative 4, again squared, is going to be 16. 11 minus 7 is positive 4, so we'll do 4 squared, again is 16. 12 minus 7, we get 5, square that, and 25. 7 minus 7, we're going to get 0 squared is 0, so we'll keep that in there just for purposes of looking at it. 9 minus 7 squared, we get 2, and that becomes 4. Okay, so now we have this set of numbers, which is subtracting each one from the average, and now we find that the variance, which is averaging the result of all the differences there. Okay, so we take 25 plus 9 plus 1 here plus 16 plus 16 plus 25. Okay, well, I'll go ahead and put plus 0 in, plus 4, and that all adds up to 96. And again, we have 8 elements, so we do 96 divided by 8, and that's going to turn out to be 12. Okay, so we found our variance equal to 12. Take the square root of that, and we get something like 3.4641. So we'll come back and look at that later and see if our output comes close to that. So that's pretty much what we're working with. So we've done one by hand, and we have our example set. So we'll try that again. So we'll come back to our program here, and let's go ahead and add in our comment statement to say, hey, we're gonna find these data statistics. We're gonna find the high, the low, the average, and the interesting population standard deviation. Okay, to do that, we're gonna need some math, because you saw some power, some exponents there, and we have a square root. So we're gonna include this new math library. Well, it's not new. We'll include this math library called CMath. Okay, that has some functions that'll be really useful for us. So first off, we're going to create this array, and we're going to reference the max in the array several times. So I'm going to create a constant to keep track of that, and it's going to be integer, because arrays, I could actually use an unsigned integer there, but just to keep it simple, I'll use an integer. And we're gonna call this constant array size, and I'm going to go ahead and initialize it to 8. Because we want 8 in our array. Okay, and that'll be 0 through 7. Okay, and then we'll define the array. So we'll double numbers is going to be the name of our array, and this is the place where instead of putting in a literal constant here, we want to put in our defined constant array size to tell us how big numbers is. That way later on, as we reference array size throughout the rest of the program, if we ever want to change this to say, let's take in 10 numbers, we can come in and change this one constant. Okay, so let's initialize that. We're going to go ahead and initialize the array to all zeros. If you don't, just like any other variable you define in C++, it won't initialize it to 0. You'll get some random data that's from RAM. So just for troubleshooting purposes in the future, we'll go ahead and put the open and close brace to initialize everything to, in the case of numbers, to 0. Okay, and so let's go ahead and get the first elements in the array, and this is going to seem strange at first because you're saying, hey, arrays work well with loops. Why are you not using a loop right now? And you'll see why in just a second. I'm just going to get the first element in the array because we're looking for what? The highest, lowest, and average. So the highest and lowest I can actually do as they're inputting, but I need to kind of define what high is. And so I'm going to do that with whatever the first element they enter. Is what I'm going to use. So I'm going to do cn here, numbers, sub 0. So that's the first element in the array, and that's also the first thing we're going to get for input. Okay, and so what I'm going to do with that is I'm going to say the highest number so far is what? Equal to the first number they give me. And then everything after that I'm going to compare to that first element in the array. So if we take a look at an array, what we're talking about here is as we enter the numbers, remember element 0 is the first element. They're going to enter 2, and that's going to set our benchmark. So the highest so far will be number 2, at least until the second number we input. And then we'll take care of that condition later. But for the first, that first number is not only going to be the highest, it's also going to be the lowest number so far, right? And that just gets our high and low variables initialized. So let's go ahead and put this numbers, again, that first element, sub 0. We'll do the same thing with lowest, is going to be the first number we input. And then the total, because we're going to have the average at the end. The total so far is what? Just that first element, so numbers sub 0. So that's a special case. We're just going to get that first element just so we have values that we want for these variables here. Okay. For the rest of them, we're going to go through a loop. Okay, so we're going to do a for loop. And where are we going to start going through the for loop? Well, remember, we already have the 0 element here. So we're going to start with I equals 1. Okay, so we're going to get the second element of the array, which is 1. Okay, and we'll stop when we get to array size, or just before, so I less than array size, so the last one we'll input is what? 7. Okay, and we're going to get there by 1, so we'll just increment by 1, and that's going to be our loop. So all we're going to do is input the next set. So I'm going to try to make this look like my first input, so the user looking at the program by how it runs may not see. So I plus 1 is just saying we're starting at I equal 1, so 1 plus 1 is 2, so it's going to print a 2 on the screen to kind of simulate this first cout statement. Okay, and it'll do it for every time through the loop. So then I'll put a dot again to make it look like that and enter a number, and then we'll just see in that element of the array, so the ith element are numbers sub I at that point. So the first time through it'll be 1, so numbers sub 1 will be input. Okay, and so that loop will input the rest of our numbers. And like I said, we can simplify this a little bit in a loop, and we can actually calculate the highest, lowest, and total. And I just realized we need to declare those variables right as we use them. So I'm going to double highest and go ahead and initialize it. Okay. Previous to this, it'll get replaced when we get to this line in the code. So we need our if statement to say, okay, well, what happens if the next one we type in is actually higher than the highest number? Well, we're going to compare that. We'll check. So if number sub I is actually greater than the highest number so far, we're going to what? Well, replace it. We have a new highest number. So we just assign highest, which is our highest number, to that new number. Okay, so pretty simple logic. If this element in the array is higher than the highest so far, we have a new high. Okay, so just assign that. And we're going to do the same thing with lowest. So we'll go up here and declare that variable. And then down here we'll add that if statement. Okay, if numbers sub I is this time what? Less than lowest, we will have a new low. Okay, so lowest is equal to that element in the array. Okay, So pretty straightforward there. Let's go ahead and put our total in. And then we'll go ahead and, because we're finding the average later on, we're going to need to keep a running total. So total plus equal. We need to add each element in, right? And remember, we initialized it here, so we added the first element, or the 0th element, into total, but now we need to add all the rest of them in. So plus equal numbers sub I. So we'll add each element as we go through the loop. Okay, we do need to declare the average, and we'll initialize that there with the braces, and then we'll calculate average is what? Equal to total divided by, and don't be tempted to put the number 8 here, even though there's 8 elements. Remember, we have this constant defined, so we're going to do it by array size. Again, by using the constant that way, if we ever change this to 10, we won't have an error here in our arithmetic. So keep using that constant, and it's a good idea to use constants when you have a repeating constant throughout the program, to declare a constant like that, because it's easier to maintain that in the future. Okay, so that's the first time through the loop, so pretty straightforward, and we already have what? The highest, the lowest, and the average done. So let's go ahead and output those. So we'll output the highest number is highest, and go ahead and put out the lowest number is and lowest in line, and then we'll go ahead and put out the average of the number is, and of course that's in the average variable here. Okay, and so we've already got, with this one loop, the highest, the lowest, and the average, and so all we have left to worry about is the standard deviation. So let's take a look at that. We'll have to go through the loop again. If you remember from our manual example of this, we have to go through, now that we have the average, we have to subtract the average from each element of the array. So we'll do that again, but we'll have to go through the array one more time with that loop. And so this time through the loop, we're including element 0, so don't start at 1 this time. It's almost the same loop, but a little bit different. So we're going to initial int I equals 0. We're going to stop at the same place, less than the max array size, and we're still going to go by 1. Okay. And a couple of variables we need to define here. We need the total. Okay, because we're going to find the average of the difference, so we're going to need that in a little bit. And so the dev total is going to be plus equal number sub I minus the average. So we're going to subtract the average from each element in the array, okay, just like we did manually. And then once we take once we subtract that, remember we have to square it. Okay, to square it, that's where that C math header came in. We're going to use the pow function, which is the power, okay, to do an exponent. And then there's 2 arguments here. What are we taking a power of? We can actually use this whole expression. We could have done this a different way and actually stored that in a separate variable. I just prefer it this way. So this is the whole first argument of the power function, and then the second argument is going to be what power do we want to raise it to, where we want to square it. So it's just going to be 2. Okay, so subtract the average and then square it, and then add it into our dev total, which we initialize to 0 doing the brace initialization here. Don't forget to initialize these to 0. You'll get wild numbers out of memory. Okay, don't forget your semicolon. Let's go ahead and put our other variable up here. We're going to need to find the variance, and we're going to need the standard deviation. Okay, so what is the variance? Okay, remember the variance is just the average, right? The average of the dev total here. So we're going to take dev total and divide that by, again, use that constant, array size, the declared constant. So if we change that, it works, okay, without too much maintenance. We just change it in the one place up here at the top. Okay, So now we need to find the standard deviation, and we're going to take the square root of what? The variance, right? So take the square root of the variance here, that's going to be our standard deviation. And we need to add the output statement, so the standard deviation is, and just our standard deviation variable there. Okay, so let's try this out. So let's go up here and compile and run. Okay, and we get enter a number. So let's enter the same numbers we did in our manual calculation. So 2, 4, 8, 3, 11, 12, 7, and 9. And we pretty much get what we expected. The highest number out of that set is 12. The lowest number is 2. The average we calculated before was 7, and the standard deviation, if you remember, is pretty close to what we have here. Okay, so same thing we got, which is always a good. So you should always do that and check your work with a manual solution to see if you get the expected answer, and if you're not, that helps you find any problems you might have in your code. So this is a good problem to kind of demonstrate going through arrays, and it kind of forces us to go through that loop twice because we need to find the average of all the numbers before we can go through and subtract the average from that. And remember, this is the population standard deviation, so if you want the sample standard deviation, you need to divide by, instead of just n, you got to divide by n minus 1. So hopefully this gives you a little bit better understanding of how arrays work, and even a little bit about standard deviation.